Hi, my name is Bill Barnes, and this is my presentation for article entitled "The Cost of a Cloud: Research Problems in Data Center Networks." So, getting started very quickly. These are the four authors. They're from Microsoft Research, and there's the link to the site you like for the article. The article was broken down primarily into four segments. The cost breakdown of data center networks, agility, what they were referring to agility, but it was primarily how well we're utilizing the data center resources. A small area they were calling incenting desirable behavior. This was more along the lines of what can we do with developers and how can we potentially alter maybe the business or pricing to meet needs and better utilize the data centers. And the last one was their geo-distribution, which was more aligning up where we should put data centers and whatnot to minimize costs, maximize resource assignment, so on and so forth. So they started off by going into the clouds and how expensive they are, where the cost breakdown is in the clouds today. This was the chart that they presented for cost summary. 45% of the cost today is currently going into hardware. This was assuming a server lifetime of 3 to 5 years, if I remember correctly. The one that surprised me most was 25% of the cost, and this was something I was unaware of, was in the power distribution and the cooling. And this was more the infrastructure, not necessarily the direct power draw, which would be just your electric bill, but the infrastructure around supporting data centers. Power draw was just directly how much power are you consuming, and then they had the networking costs, which we'll get into later, but that's ISP costs and the equipment involved there. Essentially, then, very briefly was described if you wanted to expand a cloud, and moving forward to this cloud computing, a lot of these data centers will need to become bigger, or cloud computing centers, whatever you want to call them. Expanding hardware is not cheap, and there's always, you are at higher risk of the over-provisioning when you do this. Also, you have to make sure that inside these data centers or within the data centers you're not segmenting too much. Power also becomes costly. As you scale these up, these increase your cost more likely than, these will increase cost more so than the profit you will most likely be, or revenue you will most likely be bringing in inside the current model. And that's where they were proposing the model has to change. This was a kind of a high-level breakdown of, if you had a data center of 50,000 servers, although in their description a lot of these cloud computing centers and data centers are approaching 100,000 servers, how much it would cost. Servers are costing roughly $52 million a year for 50,000 server maintenance. And this, they believe, was only at 10% utilization. One of the problems I had with this article is they didn't go into a lot of detail. I'll cover this later. They cited a lot of the articles, but we're not going to, oftentimes not reading an article, we're not going to go off and read the cited article within the article. But a lot of detail was missing at times, I felt, from this article. But moving on, for the infrastructure and the power distribution to support 115 kilovolt cost, that's $18.4 million a year in the power distribution. And then using a system called power usage efficiency, and hoping that most of these data centers are operating at an efficiency of 1.7 was the scale they were using. They said this is 9.3 million a year. And they said still estimate networking, even though networking costs have come down greatly in the past 5 to 10 years, at $5 per Mbps per month. How do we reduce costs? Servers and hardware is sort of a fixed commodity based upon what the market is currently selling them at. Really can't be lowered. So essentially what they were calling out, and they call it in later sections, was you have to increase the utilization and agility. Infrastructure, they were big fans of actually removing a lot of the infrastructure and using geo-distribution to essentially be the failovers, if you will, that a lot of the infrastructure is supporting right now, because the infrastructure itself is the failover. The infrastructure costs are primarily in the failover mechanisms. Another thing, power. There's really no clear improvement. We have to optimize better with usage of hardware. Network. They talked more about site location and where to locate these, and they went into greater detail in geo-distribution. So, a couple of their theories, they just said in their theories and perspectives on costs, they said idle hardware is a loss of money because you're not utilizing your resource. Kind of obvious. This was referred to later as you're in a trough if you have idle hardware. Resiliency in the system level. Again, this is more like have your resiliency not so much in your infrastructure, but use the data center layout, which I'll show maps of later. Some of my thoughts on what they were doing and what they were referring to was if you want to fill in this trough, I was thinking in reading this, things like deferred services would be a great thing. I'm sure, I haven't investigated, but I'm sure a lot of like AWS is offering this in some regard as well. The Washington Post example, did this need to happen immediately, or could a sliding scale been developed where, okay, I need this computation or I need this search done, I need it before the next 2 weeks, or maybe I need it within the next 3 days, and have a sliding scale upon when it's delivered. Basically, just like you would with a parcel carrier. So you have overnight, you charge more for it, or you have just standard, you charge less after 5 days. But a couple examples that we're thinking of was purchases. A lot of online stores, if they're willing to, could potentially sell their services or get their purchases rolling, and a few hours later do the billing. If it's not needed right away, if they're willing to do that, they can bill, I'm assuming as long as they bill within the 24 hours or within some calendar period that meets their goals or financial market guidelines, they'd be willing to do that. Since I was thinking of purchasing, I was thinking of inside an office processing paychecks. If you're on maybe a biweekly pay period, you reach that Friday, you just say, hey, you know what, I need the paychecks processed and the amount distributed within the next 3 to 5 days. And then you fill in a trough, not using peak usage, but trough time to do that work. Another one also, just because I've worked a lot with monitoring services, is monitoring services, and actually typically a lot of people do run monitoring services, or at least data mining of monitoring services in trough times already. But that's just another thing. A lot of these data services could kick in potentially and do their monitoring of their own kind of hardware and their own system during these off hours. And I'm sure most of them do that regardless. So agility and geo-distribution, I had troubles with some of these areas just because, and again, I'll cover this just in my overall review. It seems like they were reaching back and forth and talking over both content in these areas. But I think what they were talking about with agility was somehow is data centers, if they're more distributed better, or if they're distributed around what work gets put where, or where the highest usage is, where the better power supplies are, you can be more agile. And agility actually, in their reference, was also covering inside the data center itself, the networking agility. And I'll cover that later. I'll cover it right now. So this was probably the most technical section of the article. They were talking about actual routing and network and load balancing inside of the data center. Their big focus on this was how costly and timely routing and load balancing was, and how easy it is for data to be fragmented. They basically referred to it as an overall kind of organizational problem. Yeah, again, one of the solutions they were proposing, the second bullet point, was, I think, a research theory of direct server connectivity. Again, I know they had a reference to another article within it. I didn't look into that, but they only called that out as their only way to reduce cost here. But they did primarily say that the routing was the biggest bottleneck. The system they called out, which I'll show in the chart in a second, was using something called VIPs and DIPs for routing. VIPs were virtual IPs, DIPs were direct IPs. And if we come to this model here, what we can see is all the traffic is coming in from these broad routers and access routers, and then moving down into what they called the layer 2. That was the layer 3 doing all this routing, and now they're into the layer 2. When they assigned operations from applications from layer 3 to 2, they assigned it with a VIP. So at layer 2, these LBs, these load balancers, were using VIPs, and then they were basically passing to all these switches into the machines below the operations or the traffic to something called a DIP, which was a direct IP address. And in this layer 2 this layer 2 was subnetted. So layer 2, this single layer 2 domain, what they're calling, is essentially its own network. The biggest problem being was when they actually needed to go back up to layer 3 and to go over, now you have to literally access another network. And another thing you have to do is you have to access these routers, and these routers are literally the busiest and most oversaturated, according to them, components in this model. So I actually found this kind of interesting, just the whole layout and the architecture. Probably just because I don't have too much experience in networking. Most of my experience has been in embedded systems. But I could appreciate them calling out the problem and how basically almost as if you have to use a certain layer 2 domain, make sure you get it right, and you can do it from start to finish in there, and you don't have to access another one. The next, they had a short segment called Incenting Desirable Behavior. I liked this. Kind of matched up with what I was talking about before in regards to deferred services. But to read this real quickly, ensuring least committed capacity with fixed minimum cost is always used as a safe way to improve efficiency by setting prices that vary with resource availability and by incenting service developers to differentiate demands by urgency for execution. Workload can be shifted from peak to troughs. So I didn't think they were so much hinting on the concept of what I was calling deferred services, but what I believe they were trying to do here was figure out, if I'm a developer and I'm doing so many operations, maybe what I can do is I can set up something like almost a semaphore, and I can set it up for 20, and I stop at 20. So once I'm at processing 20, you know what, I say, I don't need to service anymore. I'm just going to hold. And basically I queue it or I store it for processing later. Maybe I can use a model where I throw that in storage, and that's cheap, and later on the CPU is what I'm using, and that's expensive depending on the model you're in. And then based upon, I adjust the semaphore and I set it to 50 if I'm in these troughs, because I've queried the service and they say, you know what, now I'm in a model where I'm very low on utilization, I'll drop your price. And so developing models or APIs that these service developers can use and basically have adjustable price models, I believe that's what they were trying to lead at. This is how I interpreted it. So there's another problem I had with the article, is I felt they were vague, but again, I'll discuss my pros and cons of this article here. The last section they had was called geodistribution. They called out two specific problems with our two real-world occurrences where geodistribution failed. Google and Amazon. Google had a 20% revenue loss when their searches increased as much as 5 seconds, and Amazon's was 1% sales decrease when a delay was added to websites of as little as, I think, 100 milliseconds. So what I saw from this was just not so much even geodistribution, was these services, people are expecting them to be immediate for the most part. And when they're not, these companies are losing money. So the latency is a big issue for these services. Besides all the problems of cost and all that, just from a business perspective, Amazon and Google have set a model where they need to have immediate response time almost. They equated these problems to geo-distribution. Again, I didn't dig through the actual references they made in here, but I trust that it was based upon what they were citing. So this was a model I was using. I kind of inferred what they were talking about from geo-distribution, and this is what I gathered. So I chose Massachusetts. I'm from Massachusetts. In a simple model, the best data center or cloud computing center, whatever you wanted to call it, would probably be in Boston. That's where the majority of the traffic would be. And that data center could probably service most of Massachusetts based upon scale and whatnot. Maybe some of Maine and up to New Hampshire or Rhode Island, who knows. But if you were just going to pick one data center, you'd probably put it in Boston anyhow. But this was the problem they were saying, is this model doesn't scale well, as these data centers are very expensive. They have all these failover systems. Also, they're not optimized for usage based upon people in Boston are not always accessing the same content as petite people potentially in Framingham or out in western Massachusetts towards Amherst and whatnot. Example would be potentially news sites. News sites in Boston are not, people accessing news in Boston are maybe not be the same as the people accessing news out in Amherst, so on and so forth. So if you went to a model, maybe something like this, where now you potentially have a data center that's located further away, and you just have a micro data center in Boston. And they can service that a little better. And now with the data center out in Amherst, you're not in a major metropolitan area, and power is probably cheaper. And potentially these resources you're looking at, just overall cost is just cheaper because you're not in metropolis. You're not in a major metropolitan area anymore. And since you're using micro data centers, maybe you have one, almost for sure you'd have one in Boston, and you maybe have one down in Taunton and one out on the Cape. And now they can kind of be the failover for each other. So if the Cape goes down, users can go to Taunton or potentially Boston instead, and they're networked between each other. And you still have the major data center, and maybe that major data center is hosting most of the content still, or is the Uber backup if needs be. However, when I thought about it, I think the model they were but before I move on but now since that data center is further out, potentially now it can service further out west and maybe into Albany, New York, and down to Connecticut, so now you've expanded the network further out. But I think this is more of the model that they're looking for, in that now you just have the micro data centers, and so they will always fail over for each other. So if Boston goes down, we go out to Amherst or go down to Taunton, and they're networked between each other. And now none of these systems have the infrastructure of backup generators and uninterruptible power supplies and so on and so forth that were that, I believe, 15% or whatever cost, I think actually it was 25% infrastructure cost that these data centers are really chewing on. And latency could even be better approved, whereas in the first model the data center was all the way only in Boston, and maybe western Massachusetts is having a harder time with latency. I think most of them would be using fiber optic now, but maybe they're not, and in this model maybe they don't need to use fiber optic because now traffic is closer to each other. So what I believe they were inferring was that we are better off potentially using a system for failover and a system to address latency issues, and not necessarily adding the infrastructure that a lot of them do to. That was essentially the article. Some of my thoughts on the article, to start with the good, I felt like the authors did have good insights. I felt like they described the problems well. They saw it as a scalable problem moving forward. And I really felt like they covered all aspects, particularly regarding cost, of what the data centers are currently facing. I thought the layout and breakdown on cost was good. I thought the article was succinct. I thought it was really to the point. The bad thing was I didn't think they offered too much in the reducing the costs kind of category. In each one of these areas where they were calling out agility, geodistribution, they had a small section they'd call reducing the costs, and this really didn't cover much. However, to be fair, the article did look like it was more talking about the problems and not how to address the problems, so can't discount them too much for that. One of the bigger problems I did have was I felt like the article was very, very vague. They did have lots of references to other articles. There were notations to other references. However, in my opinion, when you're reading an article, you don't want to go off and read other articles referencing it. So I thought this was kind of poor. It was poorly written. I had to infer a lot from it. I doubt that was the intent. This article would have greatly benefited, I believe, from just a case study where they just said, here are the problems. Oh, and by the way, here it's happening at Amazon in this regard. And here's the agility problems Amazon is facing. And just taking these problems and then constantly referring to a potential case study would have gone a long way, I believe, with them. And there was a good amount of redundancy. And actually, redundancy and confusion in the article. The agility section was referring to content in the geodistribution section at times, and there was some jump around and back and forth that I didn't feel like it was talking about one point, addressing it all the way through, and moving on to the next. Overall, I did enjoy the article, though, and particularly them pointing out the problems with inside the data center, the network agility, and the geodistribution. I was able to think more and more about it just by their kind of high-level description and infer and kind of even think of what I thought would be good for geodistribution of data centers. So that's my presentation. Hope you guys enjoyed it. Please post questions, comments on the wiki. And thanks for listening.